The session today is running JD Edwards on SQL Server in OCI. Kind of a little bit of a counterintuitive session. You would think OCI, Oracle, I'm going to run an Oracle database there. It's the Oracle Cloud. It's an Oracle application. Why would I want to run SQL Server? Especially, why would I want to potentially convert from something else to SQL Server?
I'm Angelo Rosales. I'm the IT director at Dermalogica. We're in Carson, California. Glad to be here, sharing the stage with Paul.
Thank you. And Paul Scheer, I'm the CTO of DeNovo, and interestingly enough, was fortunate enough to be the project manager from the DeNovo side on the project that we're about to talk about. So our agenda for today, introductions we've done. We'll talk a little bit about our respective companies. Angelo will share some of kind of the background and the context around why we did the project, kind of what pain points were that they were wanting solved. We'll look at kind of the key objectives that they were looking at achieving, and then ultimately where did we get and how did we get there?
So a little bit about Dermalogica. So Dermalogica is a professional grade skincare company. We were founded in 1986, and we are incorporated in Carson, California. Our company focuses on two things. One is professional grade products, and then the other one is education. We have a global reach of 100 countries. We've educated about 100,000 skin therapists worldwide. Our educational background with the International Dermal Institute, we educate about 75,000 skin professionals worldwide. And so basically our focus with modernizing our backbone with JD Edwards took us to this journey.
So a little about DeNovo. We are a JD Edwards managed services company, actually an Oracle application managed services company. We do JD Edwards, EBS, and Oracle Cloud applications. And where I live is basically with those first two. And I joke that I am at the intersection of modern hyperscale cloud and all things JD Edwards and EBS.
We started our journey on-prem with our JD Edwards, and we've migrated to OCI. With that migration, we had a lot of integrations with our data warehouse, which is running in SQL. And we had so many integrations with other applications that it required us to replicate Oracle database back into SQL. So there was a lot of friction and a lot of overhead to do that, to continue our operations. And so with this project, it kind of helped us with the latency, with the improvements, and better process and cost savings as well.
So when we got involved, you were already running on OCI at that time.
Yes, we were.
And but back when you were on-prem, you were SQL Server originally.
We were SQL Server, and we converted to Oracle database.
To an Oracle database, which really, you're thinking about OCI makes a lot of sense. Why you did that, but the problems that you're describing with your data warehouse makes a lot of sense too in terms of why you were occurring them. So kind of some of your challenges that you were having as an organization.
Yeah, so we had a lot of latency, and reporting was it wasn't as real time as we wanted it.
Now, and when you said latency, you mean from the data that's getting modified in JD Edwards to the time it appears in the data warehouse.
Exactly, yeah. And then sometimes there would be some failures, and we had to troubleshoot the ETL and rerun the whole process again before we actually get good numbers coming out of our financial reporting of one of the areas.
Oh, well, what was the impact to the business whenever that would happen?
It just slow decision making. Some of the operations have been stalled, and it becomes really a lot of overhead for us, and then the IT cost is also part of that.
So how was performance within JD Edwards itself?
JD Edwards occasionally will get some stuck processes and some latency with the users, but it doesn't happen quite often. But it was there's a big improvement now than we had before. Not to jump into.
I was going to say, let's not get to the punchline just yet. So when we started working with Angelo and kind of versus just taking what you have, how can we tweak it a little bit, how can we move it, we really wanted to understand what those organizational challenges are, and the data latency and the slowing down of the operational decision making was kind of one of the big flashing light items. So kind of digging into it, how that whole ETL process was working, we just asked the question, well, what if we didn't have to do those ETLs at all? What if we could simplify everything that we were doing, and then just as far as data replication goes, just natively use the functionality that's built in SQL Server to do SQL to SQL Server replication. So we went from Oracle Database 19c to SQL Server 2019 EE. Would have gone a little bit higher, but this was kind of constrained by the tools we were running on at the time. So why SQL Server on OCI? So I already talked about before kind of reducing complexity. We'll double click on that a little bit. Improving performance and lowering cost. So this is pictures of one of SpaceX's first engines, the Raptor 1. And I don't know how clear this is kind of from the back of the room, but if you see it, there are a lot of parts. This is very complex. It looks very, very intimidating just looking at it. It was a very expensive platform to maintain. It was still a quantum leap beyond kind of what we had traditionally had up to that point. But still, there was a lot of complexity to it. And one of the big things that he talks about with what he calls the algorithm is removing any unnecessary parts. It's like, why is this here? Why do we have it? What value is this actually bringing? And trying to get something down to the simplest state possible. So what you're seeing here on the right-hand side with the Raptor 3, this was their final state. That's still not something that I'm going to be capable of working on, but it wouldn't scare me nearly as much as that Raptor 1 would. So that's what we wanted to do with this project. We wanted to reduce as much of the complexity, eliminate moving parts wherever we could. The bottom line is complexity has cost. And sometimes that cost is real dollars. Sometimes that cost is loss of organizational efficiency, that slower decision making that we were just talking about. So on the kind of on the real dollar side, one of the big areas was eliminating that ETL process. So third-party software product that was doing that got removed. The Oracle database itself, which was, the license were included and baked into those fees, that got removed. Now, kind of very context specific. I know SQL Server, you already had the licensing sitting on the shelf. So there really was an additional cost for that, but that's one of those things where mileage may vary. Just because the number's not in one column, you want to make sure you're accounting for all of the numbers, no matter what vendor you're happening to pay. And then the last one was really simplifying disaster recovery. So by kind of moving off of the Oracle database, before they were using DataGuard to do all of that replication to database in another region. Now we're just using volume replicas. So literally the underlying disks that all of JD Edwards is running on, including the databases, are continuously, asynchronously being replicated to another region. In the event of a DR, we run some code, stand them up. You're not even doing a recovery exercise because the disks are already there. You're just attaching them and booting them up.
So yeah, that 20% cost savings, I might have undervalued that a little bit, but operationally with the software and the improvements in the processes, we've gained a lot, with this new, improved, and efficient process that we have. Not relying so much on the ETL and the downtime that sometimes cost us.
So we lowered cost, so we talked about that, but what about improved performance? So how did we go about doing that? So, SQL Server on its own isn't just somehow magically better or faster. At the end of the day, a lot of it comes down to how you're using the database. And JD Edwards very strategically made a decision 25 years ago that they weren't going to do anything fancy within the database itself. They were going to go with a least common denominator approach. We're going to do inserts, updates, selects. We're not even going to enforce data integrity at the database level. We're going to do that at the application level. They abstracted a lot of what would traditionally happen at the database. It's in the application as well. So something I jokingly refer to as Paul's Law of JD Edwards performance. 90% of the time, what is bottlenecking your JD Edwards experience is the database. And 90% of the time on the database, it's disk I/O. Disk access patterns, for the most part, are like 98% reads on a typical JD Edwards database. About 2% of that is writes. So I want to figure out how can I make the database itself faster. The magic fast button. And by the way, I'll put an asterisk here. This is also true on the Oracle side. So Oracle has a feature called advanced compression. So although we're talking about SQL Server, you can also do the same thing on the Oracle database. So we implemented database compression. So when we were coming off of the Oracle database itself, it was 893 gig in size. Not a terribly huge database, but not a small database either. But based on how that database was originally sized, about 10% of it was setting in RAM or setting in SGA. That meant that if a select came in and those data pages weren't found in that 10% of RAM that was cached, it was having to go out to disk. And anytime you go to disk, it's hundreds of thousands of times slower than if you find the data in memory. So when we went over to SQL Server, when we initially transferred the data over, database was roughly about the same size as it was on Oracle. There was a little difference, but it was marginal. Then we ran page level compression on both the tables and the indexes. And we got it from that 893 gig down to 150 gig. So the really cool thing about compression with SQL Server is those data pages stay compressed in RAM. So what this means is for every 1 gig of RAM that you have allocated on the server, you're storing between 80 to 90% more data in that 1 gig. It is like I said before, it is the magic fast button. I'm going to date myself here. Does anybody remember on your 386 that turbo button? This is that for JD Edwards. So the data pages are compressed in RAM. So here, this original database, I think it had 64 gig of RAM. This one we allocated with 128. Where actually I was talking with Neb a couple days ago when we do the code current and get this to SQL 2022. Yeah. It's like I want the whole database in RAM. RAM is cheap. OCI, it's like $1.13 per gig per month.
The good thing is you get it with standard edition too, right?
You do. So the only asterisk with standard edition is for compressed pages, you can't use more than 32 gig. So standard edition will allow you to have up to 128 gig per instance, but if the data pages are compressed, they can't exceed more than 32 gig out of that 128.
Okay, so there is
That was a hard-learned lesson on my part. So 80% more of the data pages, or 80% of the database is sitting in RAM. Anytime that we still have to go to disk, each physical I/O, those things that are hundreds of thousands of times slower that I was talking about, each one of those is now returning 80 to 90% more data per I/O. So it's like a twofer. You've gotten yourself in this really cool virtual cycle. If anyone can't tell, I get really excited on the topic of database compression. I mean, this literally is a game changer. Anyone that's running SQL Server, you already own it. You have it. It's just a matter of implementing it. Go home and do so immediately.
Do you, Paul, do you go for the blanket approach of just run a script to compress everything, or do you go for like, let me just go for the top 10? You go for the blanket.
I go for the blanket approach. Yeah. Now the only thing I don't do that on is in serial objects. Yeah. Actually any of the blob tables. Yeah. But other than the blobs, just compress it.
So you do system as well, the whole lot?
Not really.
No?
Every once in a while on some of the larger history tables, if I have a customer that wants to maintain like the F9612, the security history table.
Yeah.
We'll compress that.
Yeah, low hanging fruit.
So, what were the results? So one of the things that we do, and I jokingly refer to this as the misery index. So we take a look at all of the batch processes that are running. We look at the number of frequency, the amount of time that they ran, but also what was the total aggregate wait time across all of those jobs, and figure out what is actually impacting the business the most. The job that you see with the biggest wait time, it might only run once a quarter, and it's not really impacting the business. So we want to find out what kind of moves the needle for the business, and use that as kind of the gauge of what we're looking at. Go ahead and go to the next slide. So what you're seeing here with bars, the blue bars, these are the number of times within a given month that the job is run. And then the line, and it might be a little bit hard to kind of see it, but the line that's going through here, these are records processed per second. So one of the problems that you have with looking at batch and using it for comparison purposes is one time you might run it over 1,000 records, and another time you might run it over 100,000 records. You're going to expect those run times to be very different. But by taking the number of seconds it actually ran, dividing that across the number of records it processed, that's how we get these records per second calculation. So what you're seeing here on the right, this is while it was still running on Oracle, and this is after we re-implemented everything on SQL Server. So we went from, let's call it 160, 170 records per second to roughly 300 records per second. And remember, we use this as kind of the bottleneck on the database. There's other things that are also kind of constraining the performance on the batch side. Just kind of more of the same. Here we basically doubled the throughput on the job. You keep going through these. There's going to be go ahead and go to the next one. And this one's my favorite. So we're not saying that this is 5 times a better solution than what was there before, but you know, the data is the data. So around 4,300 records per second processed to we're right now somewhere around 25,000 records. And so some of the difference that you see is just kind of the continual tuning that's being done on the database side as we find areas that we're able to take advantage of. So kind of all of this brings up, so how did we get here? How did we get from this right-hand side to the left-hand side where we're seeing all of these improvements?
Yeah, so we really did a good teamwork with Lenovo as far as project management. So we made sure we followed a good, clean path where we created our dev instance. We did our unit testing, our UAT, and then we triaged that with rate logs, with my architect over there, and we made sure that we are achieving our business goals and before we actually jump into a go live. So there was a lot of integrations, like I said, microservices that need to be rebuilt with the new OCI, and those were fully vetted, fully tested. We did runtimes, like that's why we've gained some of those improvements, and we knew before we went live that we are actually gaining those improvements and we are reaching those business goals. By the way, this project plan, he coded this. This is not a regular project management. And when he was out and I was trying to take the lead, I couldn't change it because he coded everything. So this is how fancy Paul can get with project management.
So I refer to this as that time I accidentally wrote a project management module. I wanted something just very simply to represent a project plan for sales purposes, for illustrative purposes. And the next thing I knew, I had a full-blown project management model, which would do dependency calculations, resource leveling, and everything else.
And actually, funny story, that was our link, right? You did this project management for the company that I used to work for.
For Molina Healthcare.
Yeah. And I think you started that project just when I left that company.
Yeah, so the Gantt chart itself, we had so this is representing the overall project. With Molina, we had a go live, and we had like a 300-400 line project plan for that go live weekend, and we were struggling with how to provide efficient communication to executive management. And what we settled on is we took those 300-400 lines, we chunked them into probably about 25 buckets, kind of what you would see on the left-hand side. And then we just updated this every hour, and this became our status update that we were sending out.
But this really helped the project a lot because you can see some of the critical paths as we go through building up those environments and going through the testing and making sure that we reach those milestone goals.
So Angela, what was the final verdict on the project?
So final verdict on the project, as I said, I think we are in the right path in modernizing our GDE backbone. We are in a spot now that we've gained some improvements. We've got our operations. We've gained a lot of cost savings in our operations. Some of the friction overheads that we needed to do with the ETL, those have been gone now. And now we're completely evolving, working with Paul, making our footprint more on the cloud, working with Azure, moving our on-prem warehouses, data warehouse into the Azure platform. So yeah, I think we've gained so much with this change, with this project, and puts us in a better position.
So now that you're kind of not focused on firefighting so much, I hear that you're doing some pretty cool stuff
Yes.
with AI.
Yes, we are, and we're actually looking into a lot of AI agents. We're looking at using OCR, right? So modernizing some of our accounts payable. And we're also looking at in the bill of materials area where we use AI agents. The next step really is to continue to modernize our JD Edwards so we can fully embrace AI into a lot of our operations. And I think with this improvement really paved the way for us to start looking into that, other than firefighting all the time, it's like making sure our operations are running and nothing's getting stalled.
Well, thank you all so much for hanging out today.
Yeah.